It's too much work for me.
Too much work.
Yeah, no. All right, variations. Yeah, no. Variations. All right, so here's this section is dealing with variations, and this is dealing with constants. So for some of you, you'll love this. Might help you.
I'm gonna love this because I don't really.
All right. So what is a variation? What is something that when it varies? What does it mean? It's changing. Okay, so it's varying. Like some days, so it's funny because my geometry class is like, it's National Donut Day, and you didn't bring donuts on National Donut Day. I'm like, well, I do it on a lot of days that are not donut days. Okay, so come on, so. But which reminds me, we need to at least celebrate Pie Day. I don't know that we need to bring a ton of pies in, but I can probably make.
Have you ever tried my peanut butter pie?
You did make a good one.
It's amazing.
So
When is spring break?
it's Pie Day is on spring break. So probably what I'll probably try to do is the day before spring break, which is March 12th, we can do Pie Day because then we don't have any homework and then max and then break. Does that make sense? Because I don't want you to, I don't want it to go into the break. I try not to do that. So
the 12th?
So the 11th, or the 12th, yeah. The 12th is going to be, we'll celebrate Pie Day because we round up to 3.12 now for this year. Or changing pie because I want to celebrate. All right, so we'll do it that day, and we'll be able to do that. All right, so variations, it's a change, okay? So it just deals with change. Look at the equations they give you. So if there's a direct change, okay, so for instance, if y varies directly as x, then you're going to multiply the constant, okay? So if y varies directly as x, it's going to be y equals constant times x. When you see the word y varies directly, then it's going to be k times x. Does that make sense to everybody?
This is kind of like proportional.
Yeah, proportionality and yeah, exactly. Then if you see it varies inversely, if y varies inversely, well, what would that be? Y equals what? So this is directly. What would inversely be?
The opposite.
So it would be the opposite. What's the opposite? Division. So it's going to be k over x. Okay? And then what happens if you see the word jointly? Jointly. So y varies jointly as x and z, so therefore what are you going to have? Y equals x times z times k, okay? So you're going to have the constant added in, but you're going to have them multiplied when it's jointly, they're going to be adding them together, all right? The constant variable is got to be greater than 0. Why does it have to be greater than 0? Otherwise, it's going to do the opposite of making it bigger, right? It's going to make them smaller or non-existent. Yeah, because if it's 0, then it's going to go away. All right, so here's a good example. Here's example 1.
Look at that. Another term for variation is proportionality.
Yep, another name. Yep. So here we go. Ready? Are you ready? The distance of a freight train travels varies directly as the time travel. So, distance varies directly. So, distance varies directly, so using the word directly, as time. Yes? Everybody agree with that? So when you distance directly, time. Right? Has everybody got it? That's the wording that they use in the problem. Yes? If it travels 50 miles in 2 hours, how far will it travel in 7 hours? Okay, so what do we do? So this is really just a proportional problem. Okay? We can do it with just straight proportions if you want. But if you were setting this up with an equation, what would it be? What's your y? Your distance is your y, right?
You just make
Equals your k and your time, right?
in an hour they travel 25 minutes and then
Okay.
25 miles.
Right. So what do we do first? We put in our distance, which is 50, right? K, and our time is how long? What was the problem?
Time is 2 hours.
2 hours.
2 hours. Okay, so we're gonna get our K, right? K equals what? 25. Now the problem asks for what?
How would
How far would
What would, how would it be traveling if it was 7 hours? Okay, so what would we do? What's our constant now? Our constant is what? There, right? So y equals 25 times 7, which is 175, right? So that's your distance. Make sense? Now, it's a word problem, it's just using the word problems to your advantage, right? So, could you do that proportionally?
Yeah.
Sure you could, right? 50 over 2 equals x over 7. Cross multiply, right? 2x equals 350, divide by 2, divide by 2, x equals 175. Okay, so you can do it proportionally. Okay, you just gotta make sure to set up your proportion correctly.
So you don't care which way we do it?
Yeah, it's gonna matter when you do some of the other problems, but it won't matter in this case, in these variable problems. You can probably just solve them and move on. All right, next one. Next example. Q varies inversely with n. Okay, Q varies inversely with n. So what's the equation we're gonna use?
K over X.
So it is what?
Y equals K over X.
Q equals K over n, right?
Mm-hmm.
So now they give you the problem. If Q is 18, then n is 8. Q is 18, then n is 8. So what do we do? So what's my constant going to be? Times 8 times 8,
144.
K equals 144. So now, how do I solve? Because they asked for,
Q is 20.
if Q is 20, oops, sorry, 20 equals 144 over n times n times n, so 20n equals 144, divide by 20, divide by 20, n equals,
7.2.
okay? Will that work using proportions?
Yes.
Sure. Why would it? Why wouldn't it? Does that make sense? So you really can, all these, you probably can get away with just doing with proportions if you'd like to, but this is another way, and you will see it worded that way, so you just gotta keep that in mind when you do constants. That's all. All right? The next type of problem they give you is a little bit different. Find the coordinates of the foci of the hyperbola x times y equals 16. Now, what would that be? And how would we solve that? So according to this, how would you find it if I want you to find if it looks like that, right? I want you to find the coordinates of the hyperbola if that's your answer, right? So how would we go about that? What would your x and your y be? Essentially, it could be 4 and 4, right? So if you found your distance of 4 and 4, A and B would be 4, right?
Mm-hmm.
A and B would be 4. Okay, so what would your C be?
4 and 2.
A squared plus B squared equals C squared, right? So 4 squared plus 4 squared, right? So 32, C squared, right?
Mm-hmm.
C equals the square root of 32. Agreed? So are we good with that so far? Then what? What's the square root of that?
4 root 2.
What is it?
4 root 2.
5.7 or 4 times square root of 2?
Correct.
Correct?
Yeah.
Mm-hmm.
So now what? So what's our answer? If they're proportional, your foci is going to be negative 5.7 or negative 4 times square root of 2, comma, That's one of your foci, right? Would that be one of your C's? And then your other one would be what?
Oh, I see it.
Both plus, right?
Mhm.
Makes sense to everybody? Because your foci is what? C,
See,
okay? It's your C. So in this case, they gave you the X and the Y, they gave you this, and you can solve it solve for your C, and then you just plug it in. Whether you're in a decimal or you're in a square root.
In this kind of situation, would A and B basically always equal each other?
Mm-hmm. Yeah, because they're proportional,
Or,
or they're,
Yeah,
X and
X,
Y
X
equals
and Y.
16 is the only way you would go to do it. Okay? Any questions on that? Does that make sense to everybody? It's common, it's a little common sense. They're not, honestly, it's the only, they give you an example of it, but then they don't actually have you do any of the problems. So that's just an example of how to use proportions.
That makes sense.
All right.
What are they doing in 4 and 5 instead of 4 and 5?
What are they doing?
Yeah.
Doing this. What I was doing.
it's like a really.
I just
But
did
they
it.
did it like, I guess, differently.
Yeah, they did it.
it's
Cause
a
they're
little
weird.
bit different.
Yeah.
Can we
Just
do
do it the low ways.
another
Yeah,
problem,
but
like
that
trying
looks
to find-
easier.
Nope. Because there's not another problem to give you. So why don't you work on the problems that they actually are gonna have on the test and not one that actually is
So
reviewed.
I read on the book
What's that?
that with the like the y equals kx, that if you put it